Tonight I'm going to help you out with some of the problems from section 5.3. The assignment was 19 through 34 all. So I've selected 4 problems, problem 24, problem 28, problem 32, and problem 34. And I thought that I would try to work out these problems for you to try to get you jump started with tonight's homework assignment in case you're struggling a little bit. If you're not struggling, well, then you don't need to watch this video. You can just go finish your homework assignment. But if you are having a little trouble, then perhaps this will help. So problem 24 is the integral from 1 to 8 of the cube root of x dx. Now, as we discussed in class today, the secret to integrating definite integrals such as this, if we're not going to be stuck with the definition as our only acceptable solution method, or if we're not going to try to use some geometric approach, and in this case a geometric approach is not going to work because the square root of x is a curve. When we graph it, it makes a curve in the first quadrant, so we couldn't use our polygons or circles type of geometric approach that we looked at for some of the problems in section 5.2. So when faced with problems like this, then we're going to employ the fundamental theorem of calculus part 2. As we noticed in class today, the fundamental theorem of calculus part 2 only works if f is a continuous function on the interval upon which we're being asked to integrate. Now, in problem 24, we're integrating from 1 to 8, and the cube root of x is continuous from 1 to 8. Therefore, we're free to move forward. And the fundamental theorem of calculus tells us that the integral of a function between a and b can be found, given that that function is continuous, which this one is, can be found by taking the antiderivative of that function, evaluating it at b, taking the antiderivative of that function, evaluating it at a, and then subtracting that antiderivative at a from the antiderivative at b, and whichever numerical value we get, that's going to be the answer to the definite integral. So the key to doing the problem is to show, well, look at least to consider that is the function continuous, which this one is, and then to be able to find the antiderivative. Now the trick on problem 24 is to remember that there are other ways to express the cube root. The cube root is x to the 1/3 dx. X to the 1/3 dx. That's the cube root of x. And in that form, we can find the antiderivative. Hi there. And so how are we going to do that? Well, we're going to take the antiderivative of x to the 1/3. Now, the antiderivative of x to the 1/3, we add 1 to the exponent when taking the antiderivative. That's x to the 4/3. Now we're going to divide by 4/3. But dividing by 4/3 is a fraction. So dividing by 4/3 is exactly the same as multiplying by 3/4, multiplying by the reciprocal. And then we're going to represent that we're going to plug in 1 and 8, our bounds of integration. We're going to represent that we're going to do that by putting this bracket with a 1 at the bottom and the 8 at the top. So now to simplify this, or to finish the problem, we're going to take the 3/4 times, and now we're going to plug in 8. So we have to find out what 8 to the 4/3 is. Well, 8 to the 4th followed by the cube root of that, that's a lot of work. But we don't have to go that route. We can first take the cube root of 8 and then raise whatever that result is to the 4th power. So if we do that, the cube root of 8 is 2, 2 to the 4th, 16. So 8 to the 4/3 is 16. Minus 1 to the 4/3, which is 1, that gets us then 3/4 times 15. 15 times 3 is 45. So we get 45 divided by 4. So this, if you want to pause the video here, this is the solution to problem 24. So from problem 24, I said the next one I would work out for you was problem 28. Problem 28 is the integral from 0 to 1 of a sum. It's 3 plus x root x dx. Now in class today we went over some of the properties of integrals, and one of the properties that we discussed was, what do you do if you integrate a sum? And remember, the answer was the integral of a sum is the sum of the integrals. So we can break this up into two integrals. This is the integral from 0 to 1 of 3 dx, which we also have a property that helps us. And it's the integral from 0 to 1 of x root x dx. So we can break this up into two integrals, such as this. And before we find the antiderivative of x root x, we have to remember that x root x is actually x to the 3 halves. It's x to the first times x to the 1/2. That's x to the 3 halves. Now, we know what the integral of 3 dx is. From 0 to 1, we have a property. Property 1 tells us the integral of a constant is the constant times b minus a. So I'm going to use that property, and I'm going to write that as 3 times 1 minus 0 plus the integral from 0 to 1 of x to the 3 halves dx. So I now have a value, 3, for the integral from 0 to 1 of 3 dx. And I have a representation of x root x that's going to allow me to find the antiderivative. Now, the antiderivative of x to the 3 halves, again, we have to add 1 to the exponent. So that's going to be 3. Don't lose that 3 that's out front there now. 3 plus the antiderivative is going to be x to the 5 halves. We add 1 to 3 halves. 3 halves plus 2 halves is 5 halves. Now, we have to divide by 5 halves. But dividing by 5 halves is the same as multiplying by 2/5. Again, we use the single square bracket to represent that we're going to integrate between 0 and 1. And so we're left with 2/5 x to the 5 halves evaluated between 0 and 1. So here, at this point, we're going to employ the fundamental theorem of calculus, which we've already started. We're going to finish that by finding x to the 5 halves at 1, and we're going to subtract x to the 5 halves at 0. So leaving the 3 out in front that we've already worked with, 3 plus, that's going to be now 2/5 times 1 to the 5 halves is 1, minus 0 to the 5 halves, which is 0, which gets me to 3 plus 2/5. And when we get a common denominator, 3 is 15/5. 15/5 is 3 plus 2/5. That gets us 17/5. So here is the rest of the solution to problem 28. Again, if this is going too fast for you, don't forget you can back up, play it again, or you can hit the pause button and stop it and just look at the video. So that's problems 24 and 28. Now, I promised I would do 4, so I'm going to do 2 more. I'm going to look at problem 32, which of course has trig in it. That would be the integral from 0 to pi over 4 of secant theta tangent theta d theta. Now, again, it's the integral from 0 to pi over 4 of secant theta tangent theta d theta. That's not a sum. It's a product of secant and tangent. So our first method of solving this, or our first attempt, is going to be, do I have an antiderivative of secant theta tangent theta? Is there someone out there that we know whose derivative is secant theta tangent theta? Well, is there? Correct. Yes, it's secant theta. The derivative of secant is secant theta. It's amazing. Great job. So this changes by using the fundamental theorem of calculus into secant theta evaluated between 0 and pi over 4. So we can re-express this by taking its antiderivative. The antiderivative of secant theta tangent theta is just secant theta. And remember, that's because the derivative of secant is secant tangent. Now I have to find secant theta at 0 and secant theta pi over 4. To do that, maybe you don't remember secant, maybe you do remember secant. We can always go back to sines and cosines. Secant, remember, is 1 over cosine. So I can re-express that as 1 over cosine theta. If you'd rather do that, if you'd rather write it this way, you can. Secant theta is 1 over cosine theta. And so what does that get me? That gets me 1 over cosine of pi over 4 minus 1 over cosine of 0. Now, cosine of pi over 4 is root 2 over 2, right? We've worked with that angle many, many times. So this becomes 1 over root 2 over 2 minus 1 over 1. Cosine of 0 is 1. So that gets me 2 over root 2 minus 1. Now, if I rationalize that, that turns out to be 2 over root 2. When you rationalize that, multiply the top and the bottom by root of 2, you just get root of 2. So we're left with an answer there of root 2 minus 1. Root 2 minus 1. So again, the key is to find the antiderivative. And the antiderivative, is it easier if I hold it still or if I move it? Does this make it easier? Maybe not. So we found the antiderivative, and then we plugged in the upper bound and the lower bound, and we subtracted. Okay? So that was 32, and I said also I'd work on 34 for you. I'm doing the evens, assuming that perhaps you don't have access to the answers to the evens in the back of the book. Now, 34 is one of those problems we encountered back when we were working on antiderivatives. That we used this technique, some would call it a trick, in the past. What we're given here is we're given the integral from 1 to 2, there it is, from 1 to 2 of s to the 4th plus 1 over s squared. Now, we don't have a quotient rule for integration. There isn't going to be a quotient rule for integration. So how would we possibly integrate this? Well, back when we were learning derivatives, we faced problems like this then as well. And we remember, if you did, great. If you don't, I'll remind you now. If you have a single denominator, a single term in the denominator, you can split this up into two fractions. So this is really the integral from 1 to 2 of s to the 4th over s squared plus 1 over s squared ds. So we can write it like this. Well, simplifying it one step further, that becomes the integral from 1 to 2 of s squared plus s to the negative 2 ds. Looks like this. Well, we can take the antiderivative of both of those. The antiderivative of s squared is going to be s cubed divided by 3. You add 1, divide by the new exponent. The antiderivative of s to the negative 2, again, you're going to add 1 here. Negative 2 plus 1, that's going to be s to the negative 1. We're going to divide by negative 1, which is in essence going to make that a negative term. So I'm going to put the minus out in front. And now we're going to evaluate that between 1 and 2. So add some equal signs here so nobody comes and takes my degree away. And we're left with this. S cubed over 3 minus s to the negative 1. That minus, remember where that minus came from. That's s to the negative 1. When you add 1 to negative 2, the power was negative 2. Add 1, that makes negative 1. Divide by negative 1. There you go. That makes it a minus. Now we just plug everybody in. If we plug everybody in, we get 2 cubed over 3 minus 2 to the negative 1. That's what we get when we plug in 2. And now we subtract what we get when we plug in 1, which is going to be, I'll go ahead and write it out. That's 1 cubed over 3 minus 1 to the negative 1. Now I'm going to go ahead and stop there. I'll leave the rest of that arithmetic to you. That's 8/3 minus a half, right? On the left-hand side, that's 2 cubes. That's 8/3 minus a half. And then over there we have minus 1/3 minus 1. So if you just write it all out, maybe I'm not going to leave it to you at this point because it looks like it's so much fun to solve. I have 8/3 minus 1/2, and then distributing that negative, I have minus 1/3 plus 1. Well, this is something that's going to happen quite often when we integrate throughout the rest of the book. Notice the 8/3 and the 1/3 already have a common denominator, so that's 7/3, and the 1 and the minus a half leave us a half. So we have 7/3 plus 1/2, getting a common denominator there of 6. That's going to give us 14 over 6 plus 3 over 6, or 17 over 6. So I believe the final answer, if you can see around my big fat fingers there, is 17 over 6. There may be an arithmetic mistake in there, but I don't think so. 2 times 3 is 6. 2 times 7 is 14. 3 times 2 is 6. 3 times 1 is 3. 3 and 14 is 17. 17 over 6. So hopefully those 4 problems get you jump started on the homework. See if you can finish the rest of the assignment. It's due tomorrow. Remember, it's due tomorrow. Okay, I'll see you in class tomorrow. Have a nice evening.